Welcome to Holley Sniper EFI Training Part 15. In this training module, we're going to take a look at working with our fuel compensation tables. This is going to be including things like our air-fuel ratio offset table, our coolant enrichment table, as well as our air temp compensation table. We have a lot to cover here. Let's jump in and let's check this out. Okay, so let's get started. We're going to be taking a look at working with our fuel corrections compensations within our Holley Sniper EFI systems. Now we're going to be using these corrections or compensations to make sure that the fuel delivery for our engine is going to be consistent regardless if the engine is cold or overheating, or in a situation where we have our air temperature being really cold or really hot. This is going to allow us to further refine and correct our fuel calculations coming from our speed density operation, coming from our main fuel table. What we're going to do here is jump into the tutorial and take a look at where we can find our fuel compensation tables. Then we're going to break down how they fit within the fuel calculations, and then we'll take a look at a data log so that we can see what's going on with our fuel corrections and then what to look for within the data log to be able to go back in and correct your compensation tables so that you have a good target air fuel and we have our fuel correction being dialed in just exactly what the engine's going to want. So it's gonna make a little bit more sense towards the end of the tutorial, but let's try to break this down and keep it as basic as possible right now so we can understand our fuel calculations and compensations. So what we're gonna do right now is jump up here into any file that you have open. I'm gonna move up in my fuel ICF up at the upper left-hand corner, and then we're gonna go down here and let's quickly take a look at our base fuel, talk about this real quick, and then we're going to jump down here to our temp enrichments and then talk about the actual compensation tables. Now the base fuel table here represents two things. One, it represents the fuel delivery for the engine when the engine is its normal operating temperature range. That means that the engine coolant temperature is anywhere between about 160 to 220 degrees. That's going to be a normal operating temp range for any engine. This table also represents the steady state airflow as it's coming into our engine. So as we're idle, cruise, or even wide open throttle conditions, we're not going to have bursts of airflow as we have rapid throttle changes in those specific conditions. So this table does a good job at translating what that estimated airflow is coming to our engine based on a steady state operation. So the table represents 1, engine up into the normal operating temp range, 2, steady state airflow operation. It's really important to understand that because as we go through the next few tutorials talking about things like our temperature enrichment or acceleration enrichment, these are going to be modifiers on top of the base pulse width that's calculated coming from our fuel table here or the volumetric efficiency table here. So very, very important detail, very, very basic but very important detail that we definitely want to take away from this. So moving from our table here, we understand how this works, how that translates into an injector pulse width, how we bring the fuel delivery to our engine, and how we go about dealing with the table here. Let's now jump into our temperature enrichment and learn how these are tied together to our main fuel calculation coming from our VE table. If we go to our temperature enrichment, we're going to find that we have 3 different enrichments that we can work with, or 3 different ways that we can manipulate what's going on within our air fuel model. The first table here is going to be our coolant temp enrichment. This table is extremely simple. What it's going to do is add a percentage of fuel based on the coolant temperature down here below. This is a just simple 2-dimensional table. So again, we can find down here, it's -40 to 260 degrees. That's a typical range we'll find for any engine in terms of the coolant temperature it's going to be operating in. Now, what we'll find here in the way this table is going to work, it's going to take a look at whatever the coolant temperature is at within the table, and it's going to look up then what the compensation modifier should be at that specific coolant temperature. So we're finding here at this coolant temperature, this is going to be adding 10%. 110 is the equivalent of 10%. 100 here is the equivalent of no correction. What you'll notice is we're getting up to about 160 degrees, all the way up here to 260 degrees. We're seeing that the table values are set here at 100%. That means that we're not further refining or correcting anything against our main fuel table here, the volumetric efficiency table. So this is going to act as a modifier. It's a percentage of compensation. Now, why do we have this? We're going to find that when the engine is cold and it's coming up to operating temperature, the fuel is not going to atomize as well on a cold engine as it does on a warm engine. And as a result, we need to deliver more fuel so the fuel does not stick to the intake track, into the intake valve as easily. So what we're going to find is we have fuel already going to be sticking to the intake tracks, into the intake valve, we need to go and put a little bit additional fuel into the engine to overcome that fuel that's already sticking to the intake track and to the intake valve. And that is the purpose of our coolant temp enrichment table. It takes more fuel getting pumped into the engine as the atomization is poor coming out of our injectors, as the engine is running on a colder engine, as it does then with a warmer engine where everything's going to be atomizing. Normally, we're going to have that wall wetting effect really being dissipated. There is some always there, the residual wall wetting effect that the fuel as we're spraying. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.